let's talk a bit about our journey. So thanks already for contributing. There's another one coming later. You may have seen this. We will get there. And I want to, here share our experience, because I thought, workshop-wise, it would be nice to actually, exchange a bit of experience on how it went and how research data management was actually for us the gateway drug to high performance computing. And also, we wanted to go and be a bit crazy and wanted to throw in a few videos on how we actually work there, and also have a quick demo. That's why Tatiana is sitting here with her laptop actually to show that. So obviously, we now, I'm talking about we in Flanders Bioimaging, look at, we need to, data is the new oil. This is what we try to provide to our users, right? So, but there is a risk here in this oil analogy, because if we don't take care of what we do with the data, and we all have seen this, and we all had this call of the analysis computer is full again, and some user cannot access, whatever starting hurricanes that I forgot in the previous questionnaire, because everything is stored on C, and this is bad. So we need to take care of the data in some way, and we need to organize and structurize this. And obviously, we want to do this in some fair fashion and so on. And in our environment, we teamed up with an organization that's called the Flemish Supercomputing Center. And I will give a quick update on this. So when I talk about we, Flanders Bioimaging, that's a consortium of 5 universities and 1 research institute, and we do the regular stuff as that you would want to expect. The Flemish Supercomputing Center, entertainingly, is also a consortium of 5 universities where they start to build out compute infrastructure. And also, and that is entertaining, they started out a few years ago building a on-premises data center for the researchers. So this is where they came in and said, give us all your data. We try to be here competitive, cheap, but we also want to make sure that this is managed well, and that we, do good when it comes to data management. And we said, like everyone else, can we have an Omero on this or whatever? And they said, we do this for everyone. So humanities, law, engineering, chemistry, your image data is only that smart of a pie. So we try to do a tool that works for all of us. And it was entertaining as an exercise. So what they created here, and then here a lot is, also talking Tatiana with Ingrid, who was running that, building a tool called Mango that runs on iRods. So iRods is IT built storage system. It's rule-based. So this is what your phone also does when it stores your images. You have your photos from last week, still fresh on it. All the other older ones are somewhere in the cloud and are only downloaded when you need it. That's a rule that is sort of imposed on your phone. This can work for any storage, and this can work for saying we want to spin out unused data to cheaper storage even, or archive it whenever it's older than 5 years, or this kind of stuff. And it's also a system where you can use and attach metadata. And I'm showing here a quick video. This is 2024. But we are uploading some data. Here we go. It just starts. And the point is, the interface, on the manual level is very easy. I'm just showing that because we want to go further, and I show you in a split second how this goes. Elsewise, you can just put data in there, and then you can work further on this. And I'm showing you here that we can also have alternatives for that, connecting with it. But most importantly, you can have here the possibility to create some data management schemas where you can add whatever kind of information that you want. You can design whatever kind of interface you have. This could be a RAMB workflow. This could be whatever it is. And we're just showing this here to add an objective lens to the data set that we had here. And this is quite nice. We obviously can read out the regular ones that you would have attached to the files in the metadata anyway, but you can add anything like an DOI for your sample preparation and so on and so on. So this is nice. This is good. But the entertaining question that we had is, we started to interact with these people, and we, obviously had some incentives because we wanted to use the cheap storage that they had. But we also learned that we can, now start to have more opportunities, because now that our data is in a data center, we can also use their compute power that's next to it. And here I want to point to, and we will showcase this a bit later, that you have different tier levels for supercomputing power. Normally, tier 3 is what we all have, it's our desktop. Then on university level, you may have tier 2. This is smaller clusters, and then we have regional and national clusters. And it's important for us, GloBIAS as an international consortium that may collaborate. We also have, European and transnational clusters that we may have access to, where we can, execute, joint processes on or projects on, and that would be, for example, Lumi, and that's what they call tier 0. In our environment, we do have that split up in 3 different kind of stuff. You have compute part, you have the data part, and we have the cloud part. Cloud part would be something like virtual machines and so on and so on. Now, when it comes to the compute part, this was my expectation, that we have this blunt interface of command line, but it turned out that this is actually more looking like this, and that we actually have access to a number of different tools there. And I feel like this is actually starting to be, I think, a game changer when it comes to accessing this infrastructure, because I feel here, to give a bit quick credit to the EMBL, who has been paving the way here a lot for us, who created the band, the Bioimage Analysis Desktop. Just for those who don't know, it's a server-based interface where you have a desktop experience with graphical user interface where you can run on the cluster different kind of tools, and you see here Cell Profiler, Fiji, Omnipose, and what have you.